Okay, so our topic for conversation this week is going to be the excretory system. And I want to clarify a little bit because with the excretory system, there are times where you will see this identified as the urinary system. And when we're talking about the 11 body systems that the human body has, it is the excretory system, which is the system that is designed to eliminate waste from the body. Now, you have a variety of different ways that we eliminate waste product from the body, and we have covered most of these at this point in the year. We've talked about the respiratory system, which is going to allow us to get rid of carbon dioxide. It's a waste product. And so the lungs are considered to be part of the excretory system. When we sweat, we are going to get rid of urea, which is a waste product, through our skin. But we covered that when we went through the integumentary system. Then we have our solid waste, which we are going to eliminate as part of the digestive system. And so we've already covered that. So by the time we get to this point in the year, the only excretory system that we haven't focused on or structures are those belonging to the urinary system. So a lot of times you'll see the urinary system identified and kind of used interchangeably with the excretory system, but we're talking about a very specific part of the excretory system. So please understand, excretory system refers to all of the different ways that you guys can get rid of waste product. And you can do that through a gas form when we exhale. You can do that through the sweat. You can do that through solid waste. And you can do that through liquid waste. But excretory system is much, much bigger than the urinary system. So please don't think that those are interchangeable. They are not. It's just at this point in the year, we focus on the urinary system when we cover this chapter because we've already covered those other structures through the chapters that we've done up to this point. So in looking at the urinary system, there are four major structures that we need to talk about. And those are going to be the kidneys, the ureters, the bladder, and the urethra. And I will go through those slide by slide a little bit later in the lecture. So I'm not going to spend a whole lot of time talking about the individual structures quite yet. But getting an understanding of what the urinary system is. A lot of people, when you talk about the urinary system, they know that we are avoiding waste out of the body and just kind of leave it at that. But there is a much larger underlying function that the urinary system has to carry out. The urinary system is working 24 hours a day to make sure that all of your levels are where they're supposed to be. And when those levels are not where they're supposed to be, you have a series of hormones that are going to be released that will tell your kidneys to either pull something back out of what it is filtered from your blood or to put more of it into what has been filtered out of your blood so that it can be eliminated from the body. So the urinary system is going to look at things like your potassium levels, your ion concentration, your hydrogen concentration, your pH levels, sodium levels. All of these things are going to be monitored by the urinary system. And when they get too high or when they get too low, your body has to make adjustments in order to get enough out of your system so that you don't become toxic or to pull some back in and hang on to it so that you can continue to function properly. So this is a very tedious balancing act that your urinary system has to do every minute of every single day to make sure that it is keeping all of your levels as balanced as they possibly can be. It explains why your urine will change color throughout the day. If you have enough fluid in your body, you will push out some of that excess fluid when you urinate, and so that will dilute the other material that you have in your urine, making it appear more clear. If you don't have enough liquid in your body, your hormones will tell your kidneys to pull out as much fluid as they possibly can. And in doing that, they are going to make the other material that you are eliminating more concentrated. And now your urine is going to be a darker color. So that explains a little bit of the regulation process that your kidneys have to go through. So the second slide that you guys have just gives you a visual of the position of all of the structures that we're going to talk about. And the biggest one is going to be the kidneys. And you can see immediately, and keep in mind, I'm speaking anatomically, I'm not speaking how you're looking at the picture, but the right kidney is going to be positioned slightly lower than the left kidney. And the reason for that position difference is that in this area, just above the kidneys, you would have the liver. Now, the liver has a very broad side, and then as it comes across to the left-hand side of the body, it actually tapers and becomes more narrow. And so you have that difference in height or positioning of the kidneys so that there's enough room for it on the right-hand side, and then we don't need quite that much room on the left-hand side. The reason that we just don't have them straight across is because if you look at the second feature in this picture, you'll notice the rib cage. Now, the kidneys are what we call retroperitoneal. Retro tells you that they are behind the peritoneum or the abdominal cavity. So the kidneys are not centrally located as far as from front to back. They're not in the center. They are positioned more to the backside of the body. And because of that, if you have any sort of trauma to your back, there is a higher risk that you are going to do some sort of injury to the kidneys themselves. Now, with the rib cage, you'll notice that the superior portion of the kidney is going to be protected by the ribs, but the inferior portion of the kidneys actually hangs below the rib cage and therefore doesn't get the protection of those bones. So we have the height difference because on that left-hand side, by having that kidney positioned a little bit higher, we can take a little bit more advantage of that bone protection. That's why they're not straight across. Now, on top of the kidneys, you have what are known as the adrenal glands. They look like little hats sitting on top of the kidneys, and those are the glands that are going to produce your adrenaline, the hormone that would give you superhuman strength. So in times where you are stressed, you are pushed out of your comfort zone, those adrenal glands are going to dump that adrenaline into your kidneys, and you can see that they have a huge access to blood supply. So you can quickly get that adrenaline into your bloodstream and dispersed out to your body, in a very, very short amount of time. Now, you also have the ureters, which are the tubes that run from the kidneys down to the bladder, and they extend from the medial side of the kidneys down to the bladder. Now, the one thing that this picture is a little bit misleading is it makes it look like the ureters come into the top of the bladder, and that's not the case. Right about the time those ureters get down to the bladder, they will actually cut back and they come into the backside of the bladder. So you'll get a little bit different angle of this in a later picture. And when that happens, you'll see what I'm talking about. You have the bladder itself, which is going to hold on to urine until you are ready to void it. And then you have the urethra, which is going to be the tube that is going to take the urine from the body to the outside world. The picture that you have following that, the slide that is identified as the structure of a kidney, you have a lot going on here. And when we talk about the structure of a kidney, this is a process in which you are taking the blood of the body, 5 to 6 liters of blood, and you are going to continuously run it through the kidney, which is essentially a filter. And we are trying to filter out all of those things that are potentially going to be harmful to the body if they are allowed to stay in the body. So this filtering process is very in-depth. So when you look at this picture of the kidney on the left-hand side, it does look a little confusing, but it's just basically an assembly line, and I'll talk you through that here in a second. On the right-hand side of the slide, you have 2 additional pictures, and they are showing you what is called the nephron. The nephron is the functioning unit of the kidney. So just like the cell is the smallest functioning unit of a living organism, the nephron is the smallest functioning unit of the kidney. And again, we'll go more into that as we move forward. So I want to focus for just a second on the picture that you guys have on the left-hand side. Now, one of the things that we haven't shown in any of the pictures yet is the fat capsule. Because the kidneys don't get full protection from top to bottom of bone structure, what they do instead is they wrap the kidney in fat. So if you were to cut into somebody and be looking for their kidney, you would not initially see the kidney as detailed in these pictures. You would actually see a complete capsule of fat wrapped around the kidney to offer it protection. Now, once you're inside the kidney, we have a renal capsule. And this is going to be a very tough tissue that you have on the outside of the kidney to help protect it as well. The other thing that the renal capsule does is it creates a barrier between the kidney and the surrounding structures. Remember, these kidneys are filtering out material that is potentially toxic to the body and allowing you to eliminate it from your system. You don't want there to be a chance that that material could diffuse back out of the kidney tissue, and so that capsule helps hold it in place. From there, you have the two layers of the kidney. So just like with the skin, we have the epidermis and the dermis. You have the two layers in the kidney, which are the cortex and the medulla. And you have a couple of brackets there, which show you the cortex layer, and then the layer that is below that, which is the medulla. So just understand that we have a fat around all of it, a very tough capsule containing all the structures of the kidneys, and then we have two layers within the kidney, which are known as the cortex and the medulla. From there, we get into our assembly line. So you'll notice that in the cortex section, that's where the nephrons would be located. And the nephrons are essentially filters. They are going to be where your blood is filtered out, and most of the material out of your blood is going to be removed and turned into something called filtrate. Once that happens, that filtrate is now going to be run through a series of steps to figure out what needs to remain in the filtrate and leave the body, and then what material could potentially still be beneficial to the body and pulled back into your bloodstream so that you can reuse it. So again, a lot going on. But that nephron is going to filter your blood. Once it's been filtered and whatever material has been deemed as material that needs to leave the body, it is going to start the assembly line of exiting the body. So the first step in the assembly line after the nephron is going to be the minor calyx. So you'll notice that you have the fan-shaped little structures that kind of span around the kidney structure. Average kidney will have about 8 to 10 of those. And those fan-shaped structures are called renal pyramids. So the renal pyramid is going to lead into that minor calyx that I was just telling you about. So the nephron delivers the filtrate to the renal pyramid, and from the renal pyramid, it is then going to advance into the minor calyx. Minor calyx is not something that we really talk a whole lot about or that a lot of people have background with. So I'm going to put another name to it that you might be a little bit more familiar with. Think of the minor calyx as a funnel, a small funnel. Now, what's going to happen is you have all of these individual renal pyramids that are draining this filtrate material into those minor calyces. So what eventually happens is those minor calyces fuse together. And when you have two or more minor calyces that fuse together, they turn into what we call a major calyx. Again, not a term that we use on a daily basis. So instead of a major calyx, think of it as being a bigger funnel. So all we're doing is we're taking this filtrate material and we are funneling it closer to the exit. So we go from the renal pyramid to the minor calyx to the major calyx. And then once you get the major calyces and they all fuse together, that is going to be the renal pelvis. So again, we're just taking them, we are fusing them together and getting these larger and larger funnels, but that's all that they are. They're just bigger funnels than the one before them. So we continue the journey forward into the renal pelvis, and eventually the renal pelvis is going to direct that material to the ureter, which you can see the bottom left there. So a lot of new terminology, I get that, but even with all that's going on there, you're basically just funneling the filtrate material and eventually getting it to where it's going to be eliminated from the body itself. Now, in that process, a couple that we didn't talk about, if you will find the renal papillae, it is the third one from the bottom. The renal papillae is nothing more than where the renal pyramid and the minor calyx fit together. So where those two structures combine and meet as one, that is known as the renal papillae. You also have the renal columns. They are just about dead center of the list that you have there on the left. And the renal columns are nothing more than support structures. They are bundles of tissue that you find between the renal pyramids just to offer them support and hold them in place so that they don't collapse and run into each other. Now I'm going to not talk so much about the nephron quite yet because we are going to get to that in a future slide. So just checking my time, sorry. Now with that, if you look at the slide just below that, it gives you an image of the kidneys and the adrenal glands, and you have the two arteries, major arteries that are going to serve the kidneys themselves. So you have the abdominal aorta that you can see there, you have the inferior vena cava that you can see there, and then branching off of the aorta, you have the renal artery going into the kidney. This is going to bring the blood that needs to be filtered to the kidney. It will run through the kidney and get filtered, and then pulling it back out, you have the renal vein, and that is going to then just start directing the blood back to the heart to do the gas exchange with carbon dioxide and oxygen itself. So just looking at the major blood supply, blood flow that you have going in and out of the kidneys. The slide is formed. So the formation of urine is essentially going to be a three-step process. And I've pretty much talked you through this. I just didn't use these terms. I wanted to use more general terms because in looking at the nephron, I didn't want to be throwing a whole bunch of new vocabulary at you as well. So with the formation of urine, three major steps: glomerular filtration, tubular reabsorption, tubular secretion. We've already talked about all of these. I'm just going to apply it back to what we've already dealt with in our lecture. Glomerular filtration is when the blood is filtered in the glomerulus, and whatever is pulled out of that blood and turned into filtrate, that whole process is known as your glomerular filtration. So cleaning out the blood and pulling out most of the material in your blood. Tubular reabsorption, this is mostly going to happen within that nephron loop, especially the descending side of the nephron loop. Reabsorption is simply telling us that anything that is going to be beneficial to the body and we need to hang on to, we're going to move it from the brown tube back over to our blood vessels so that it can remain in the body. Tubular secretion, this is that last section. Anything that is still in the brown tubes after we have finished the nephron loop. So we're on the upswing of the nephron loop. Anything that is still in that brown tube at that point is going to get delivered to the ureter and is going to be eliminated out of the body in the way of urine. Now, the next slide after this is the filter rate. So when we look at the cleaning of the blood, water is filtered out of the blood at approximately 125 mils per minute. And if you want to, through the measuring devices that you guys have, you can measure out 125 mils and see what that actually looks like. But 125 mils every single minute is cleaned out of your blood. Now, that happens 24 hours a day, 7 days a week. Body never gets a break from that. Of that, because of how valuable water is to our body, about 98% is going to eventually get pulled back into your bloodstream. So you can reuse it. If that wasn't the case, you guys would be going to the bathroom a lot more often than what you do. So I put a conversion rate in there, quarts, how many milliliters that equals, quarts and gallons. And what I want you to do is I want you to tell me how many liters of water are actually filtered out of your blood every day. And I also want you to tell me how many liters of water are actually voided. So based on that 125 mils per minute, you would determine how many total liters of water are filtered out. And then using that idea that 98% is going to be reabsorbed, how much would you actually then have left to void? And I will put this in an assignment page for you guys to do, so you don't have to remember this, but I'll write out the instructions. And then the last part says, each minute, 20% of your blood volume is directed to what? And the remaining 80% is directed where? So I'm just looking at where the blood is being directed in your body at any given time. You can use your textbook to look that up. You can use the internet to look that up, and then submit your answers. So on this one, you'll have 4 different things that you're telling me. Total water filtered in a 24-hour time period, the amount that is actually voided, and then the 20% of blood volume, 80% of blood volume, and where that's going. And like I said, I'll type that up for you so you guys have that as an assignment. The next slide that you guys have talks about the makeup of urine, and shouldn't surprise most people that a majority of your urine is going to be water content. You do have other material that is going to be part of your urine, urea, which is going to give it its yellow color. You have some other salts and ions that are going to be eliminated as well. But things that you should never see in your urine, you should never have blood in your urine. Something is not going right if that is the case. You should never have protein in your urine. So when you are doing a urinalysis and you are testing for positive for those things, that's an immediate indication that something is not working right with the kidneys or something is not functioning in the body. And you have so much of these that the only choice your body has is to eliminate it through your urine. Diabetics, they get such a buildup of glucose in their body. You should never have glucose in your urine. But if you have no other choice, if it's not getting consumed by your cells and that glucose builds up, eventually it will get voided out through your urine. And that's a test that they can do for diabetes, is finding that glucose present in the urine. So that's just a quick rundown of the makeup of your urine, what you should find in your urine, and what would be a normal process. The next slide that you guys have talks about the ureters. The ureters are going to be the tubes that are going to take urine from the kidney down to the bladder. And so the ureters extend from, like I said, the medial side of the kidneys and extend down to the bladder itself. It talks about them being 25 centimeters long, and if you kind of put the conversion to it, 2.5 centimeters is going to equal 1 inch. So we kind of work more on that system. If you want to do that conversion, you can. Okay. Now, the ureters themselves are going to run parallel to your vertebral column. And you can see that in the picture, how they run from an up to down direction. And then they link with the bladder on that posterior side. So all that the ureters do is they transport the urine from the kidneys down to the bladder. And the one thing that you should keep in mind is you have millions of nephrons in your kidneys, and they filter out this liquid on a continuous basis. But getting the urine from your kidneys down to your bladder is not like you turn on a faucet and it just pours down. It's a drop by drop process. So getting the urine from your kidney down to the bladder, it's going to come out of the ureter drop by drop by drop. And so it takes time for that urine to build up in the bladder, just because of how the delivery method happens. Now, the bladder itself is a bag it's a muscular bag, but it also has the ability to stretch. It's made up of what's known as transitional epithelium. Way back in the beginning of first semester, we talked about that. But transitional epithelium has the ability to stretch. And so when your bladder is empty, it will shrink down. And as it fills with fluid, it will then expand to accommodate that additional liquid. Now, the average bladder is going to hold somewhere around 13 ounces of liquid. So if you think about what a 12-ounce can of soda looks like and just add a little bit more, that's about what the average bladder. Some people are going to be a little bit less than that. Some people are going to be more. That is an average. But what happens is the inside of your bladder is lined with nerves. And so as liquid spills into the bladder, it eventually reaches a level where it starts to trigger those nerves. So it has to build up to a certain level, and then it hits those nerves. And those nerves will then tell the muscles to contract. And those muscles contract. And when they do, that's your sensation that you have to go to the bathroom. As more and more of those nerves get stimulated, the intensity of those muscle contractions will increase, and your signal that you need to use the restroom will become more intense. So that's what your body, or how your body tells you that you need to go to the bathroom. You would not want that signal to come as soon as you had any liquid in your bladder, because like I said, it's coming in drop by drop. And so if you think, if you have a leaky faucet, how much time it takes for that to build up. Like I said, you want those nerve sensations to wait until you have a certain amount in your bladder before they alert you. The next slide that I have on there is just a comparison between the male and female anatomy. And I wanted you to take a quick look at the urethra in the male versus the female. So picture A is a diagram of the female anatomy. Picture B is the male anatomy. And if you find the urethra in both, and you have the lines going to each one, in the female body, the urethra is going to be between 3 and 5 centimeters long, 3 to 5 centimeters. In the male anatomy, it's actually going to be 7 to 8 inches. So we've got a huge size difference, 3 to 5 centimeters versus 7 to 8 inches. And if you look at the positioning of the bladder and all of that, you can see why we have the difference in length, but it translates to other things as well. In potty training, it can be more difficult, could be more difficult to potty train a little boy. And the reason for that is you have to build up muscle control to contract and hold the urine in place until you are ready to void it. When you have a urethra that is 3 to 5 centimeters long, developing that muscle control is a little bit easier. When you are trying to develop muscle control for that 7 to 8 inches, that can take a little bit more time. So sometimes you'll hear that you should wait a little bit longer for little guys to start potty training them. And that is because of the anatomical differences that we have in the male and female. It doesn't happen that way. You'll hear stories all the time about little guys that train very early, and that's great, but it all has to do with that muscle and when they get the muscle control. So even starting any child too early can be frustrating, just because if they're not to a point where they have that muscle control in place, all the training in the world isn't going to do anything. The next, or the last slide that we have, is the urethra. And I've already talked about this a little bit in that picture, but just the urethra is going to be the tube that is going to take the urine from inside the body to the outside world. And like I said, I already talked about the differences in the length between the male and the female anatomy, but ultimately this is how you void that urine. The one other difference that I didn't mention in the male anatomy, in the male, the urethra is going to be used for both releasing semen as well as releasing urine from the body. So it has two roles in the male body. In the female body, the urethra is devoted simply to getting urine eliminated from the body. So that takes care of our talk on the urinary system. And like I said, technically this was our excretory system, but we'd already covered all the other methods. So we just needed to focus on these. And in itself, there's a lot of information packed in the kidney, the structures of the kidney, the nephron, and how that all works. So I will put in the information for the leaders that I was talking about earlier, as well as the direction of the blood, and explain that a little bit more so that you guys have that. And then you have your lab activity that you need to complete. There is a video that has your instructions or some helpful information in how to get that started and going. And then if there's anything that comes up, please email me with any questions, and I will get back to you as soon as I can to help you with that process. We are getting to a point where we have had enough assignments that I did get things entered into Blackboard, so you can kind of see where you're at. And you have the TESMOs that have gone in for both the cardio and the respiratory system, as well as the lab for the digestive system and the lab for respiratory, excuse me, not the lab for the digestive system, the lab for the respiratory and the cardio. So there are 4 things that are in there right now. Please make sure that you guys are keeping up with that material. Some of the videos, because of the memory on my computer, I'm having to take down to make room for the new videos. So I don't want anybody to miss out on that. So please make sure that you are staying within the due dates so that that does not become an issue. Anything else, please let me know and I will see you guys.